Yeah? Okay. So, my name's Luke Jennings. I'm a pen tester by trade, working in the UK. And I'm here to speak to you about deployment solutions, the kind of attacks that are applicable to them, and mainly and particularly we'll be looking at one particular example, which is Symantec's Altiris deployment solution, which is quite widely used. So, a brief outline of what we'll be covering, introduction, the kind of threat vectors that are faced, the environmental concerns, and then we'll move on to looking specifically at Altiris and the defense mechanisms that should be applied in order to better protect your networks against these issues. So, deployment solutions, what are they? Essentially, they are systems for managing large networks. So, if you've got thousands of machines, thousands of servers, desktops, and so forth, it becomes very difficult actually trying to manage the consistency of their builds and the software that's present on them and updating them as well. And then deploying new systems when they're needed. And deployment solutions kind of address that problem. And one particular area where they seem to be used quite a lot is also for supporting thin client networks. In terms of my testing experience, I've predominantly tested them in more conventional environments, but my understanding is that they're often used in thin client networks as well. So why would you use them? I mean, from a business perspective, if you've got centralized management, then you've got easier management. Essentially, when if something's easier, you're going to have better consistency. If something's more consistent, you're going to have better quality. At the end of the day, it's just going to lower your costs as a business to use this software. It's going to make the job of the system administrators much easier, and all are happy, or so they should be. So why did I start looking at it? I tend to be quite interested in technologies that can lead to you compromising large networks rather than just one system. Some of the work I've done before has been on Windows access tokens, and that was something I was interested in because using the tool I wrote Incognito would mean that you could compromise large networks if you got the right tokens. This, for me, just followed on from that in that it was another technology I could potentially use to get a larger level of access when I was performing pen tests. Another point is it's used in enterprise environments, so it's critical environments. There had been security issues in the past, quite significant ones when I began looking at this. And the other point that interested me is that this kind of software is often used to actually improve security, because people want to use it to patch their Adobe Reader vulnerabilities on all their desktops and their Flash Player vulnerabilities and so forth. So you often find it may actually be used in quite high security environments as a way of trying to improve security. So if you find that it actually has critical implications of the security type, then you'll find that, I find that quite interesting to look at from that perspective. So moving on to the threat vectors. At the basic level, kind of assuming a fairly conventional client-server architecture. So in this example, we're saying that the deployment server is the server, and that has management control over all the clients. And the clients, they could be desktops, they could be servers, but in this architecture, they're just clients of the deployment server. One avenue to consider is obviously direct attacks against the deployment server itself. I mean, if you can compromise the deployment server, then you essentially compromise everything else it manages. And the other key thing to think about is attacks against the clients themselves. So if there's any change to the clients based on the way that they are set up to use this software in terms of how they communicate with the server, or whether they need any software installed on themselves, then that can have security implications as well. So the methods of conducting these attacks, well, the general ways is that you kind of got the usual suspects. So we've got direct attacks against the systems themselves, but then you also have to consider server impersonation. So how do the clients actually know they're talking to the right deployment server? Then there's obviously traffic interception. What happens if you play with the traffic going between them? Is it properly authenticated? Is it properly encrypted? And are there any vulnerabilities that could be exploited that way? And also there's the idea of a malicious client. You know, what happens if the clients themselves are actually trying to subvert the server? And do they have any further level of access because they've been configured as a client that a general system on the network might not have? So, the environmental concerns. Standard builds are something that are very useful in some regards. It's easy to manage, and often people would see them as being better from a security perspective, because if you know what's there, as long as you make sure you've got it right once in terms of security, then you can kind of make the assumption that, okay, that means all 1,000 of my machines are okay because we've got this one golden build done well, and we've made sure we push the same thing out everywhere. So sysadmin's perspective is going to be that automated re-imaging, pixie booting makes my life a lot easier, and I'm fairly happy with the security of the build now. But from a hacker's perspective, he's going to say, I just stole your standard build, now I can look at it, look for vulnerabilities, and I've got the standard admin password that's configured on your machines as well. So one thing I see very commonly as a pen tester is that, especially with Windows systems, is people deploy a standard local admin account, and for some reason seem to think often it's far too difficult to actually change that as a post-deployment step. So if you've got a way that, okay, a normal attack there is if you compromise a machine and then you're able to extract the hashes, you might be able to use that to compromise other systems. If you don't even need to compromise a machine in the first place, you can just kind of boot into a standard build, then it's even easier for someone. And the other concern is really that you're putting all your eggs in one basket here. The deployment server is the holy grail in this respect. So just like if you have a Windows domain on your environment, then the domain controllers, you have to really think about their security because they have access to everything. It's the same thing, and people are obviously used to considering their domain controllers as being critical, but I've found often in environments where people are using these deployment solutions, they don't quite think about the deployment servers in the same context. So obviously, being a critical part of your security model, you need to treat it appropriately. So, okay, that's just the basic ideas with deployment servers in general, but now we'll move on specifically to Altiris. Okay, so as an overview, I think Altiris were a software company in their own right originally, and they built their name on this kind of technology. But they're now owned by Symantec. I believe it was a couple of years they got acquired by Symantec. But the technology is also rebadged by various different vendors. So you may well have encountered Altiris deployment solution without realizing necessarily it was that technology. So they're partnered with other major software vendors. So for example, HP Rapid Deployment, all that is based on Altiris, as well as, I believe, Dell Pwnage. And they've also now they're owned by Symantec. Symantec have been pushing the software a bit more and trying to build further relationships. So they're also partnered with the Oracle, IBM, Cisco, Intel, VMware, and so forth. I don't think necessarily those ones have rebadged the software, but they are supporting it as being a way of deploying their software. And because with Altiris, you can actually write scripts that plug into it for performing certain tasks. And I believe that those sorts of software vendors are providing scripts that customers can use and say, look, this is a script for Altiris that can be used to deploy our software. So it's encouraging more and more people to use it. I think it's only going to become a more common piece of software for us to see in the future. Okay, in terms of the basic architecture, we've got a client-server model. And one thing in particular is that there's actually a software agent installed on the client. So it's not a case of just the deployment server authenticating to the client in some way and controlling it remotely. There's actually a little software agent it installs on them that connects back to the deployment server and receives commands through a communication channel. In terms of database storage, it's a SQL Server backend, and the server is then managed either via a thick client or a web interface. And they will talk directly to the database, and then there are some other network services involved that we'll come to that are involved in that as well. So when I came to first be looking at this, one thing I considered obviously was previous vulnerabilities. it was actually kind of the case that I kept seeing this software on pen tests, but the pen test I was on, I didn't really have enough time to be delving deep into this software. I could see that it was obviously installed in a lot of machines and was quite important. I knew what it did, and I'd seen from vulnerability assessments that there had been previous vulnerabilities identified. But then I was lucky enough on one pen test for it to be a long enough and big enough pen test that and that it was critical enough to the environment that I could justify spending a significant portion of time actually looking for new vulnerabilities in it to see if they affected the network in question. And that's when I began finding some interesting things. So previously, what had been identified is there were several issues of escalating privileges on a client. So going back to the agent that was installed, various people have identified some vulnerabilities in the past that would enable a low-privileged user to escalate to system. I know Brett Moore was one person that did quite a lot of work there, and there's some other people. And there was some of them were shatter attacks, some of them were file system-based. But then also there were a couple of attacks against the deployment server itself, and obviously they are a lot more significant because then you're compromising everything rather than just escalating your privileges on one system. And they were mainly, there was a SQL injection vulnerability within, not within the web interface, it's within one of the proprietary protocols that Alteryx uses. And there was also a directory traversal in the Pixie server. And one of the other core vulnerabilities someone pointed out about 5 years ago now was that at the time, you could impersonate the server because there wasn't really any authentication that was happening. There was the ability to encrypt the connection, but there was, other than that, there was no authentication. So if you were able to trick a client into connecting to you, then you would actually be able to control the client, which is obviously a very significant vulnerability. So moving on to some of the new vulnerabilities identified. Back to server impersonation. To address the issue of the server impersonation that someone pointed out years ago, Alteryx introduced key-based server authentication. So you can sort of generate a key on the server, supply it to the clients, and it's sort of supposed to be a kind of challenge response-based mechanism that will allow the clients to identify that the server is the correct server they're speaking to before they receive any commands. Unfortunately, or fortunately, depending on which avenue you're coming at it from, I found it was quite simple to bypass. And it leads to two main valid attack vectors, two main threat scenarios. And it was also made worse due to multicast. Alteryx supports multicast by default, and that means really if you've got a client that connects to a network, you don't necessarily have to be on the same local subnet in order to execute this attack. As long as the routers in between support multicast, potentially you could be exploiting this from several subnets away. I guess it just becomes a race with, if there are any existing deployment servers in a network they've connected to, it becomes a bit of a race condition between them. But if they're connecting to an outside network where Alteryx isn't being used, then you're probably not going to even have that race condition to worry about. So this is just a little packet dump. I'll show you an actual demo in a minute. The blue is my malicious server, the red is the client. Now, my malicious client has straight away sent a request to it trying to send a file before the client's even had a chance to do anything. And then the client was intending to connect and send its request for authentication, which you can see is the following red packet. But what really happens if you drill down and see it at the code level, if you're looking in either Pro, you'll see that it's just a switch statement. And obviously at some point they'd put in this key-based authentication, just added the case for that to the switch statement, but they've never really changed the rest of the switch statement to take into account the state. So if you just send it other commands, it will just process them. So it will process the authentication, and if that fails, it disconnects you. But if you never bother with the authentication in the first place, it's just a switch statement. It processes the other commands. This is a little bit cheeky, but after I found this vulnerability, I was actually looking in the system administration guide. You probably can't see that diagram very well, but what I found was in the appendix, there was this nice little flow chart describing why this was such a secure method to use to authenticate your server. And I just thought it was rather amusing having saw that and then it was such a simple vulnerability had actually been introduced. So, moving on to the first attack scenario. This is the idea of compromising laptops that have been managed by Altiris. Mobile devices really, so laptops are going to be the key one here, outside of the original network that they're being managed in. So here we'll be looking at server impersonation, and probably the main idea would be maybe redirecting traffic at Wi-Fi hotspots. Okay, so set up here I've got a Windows 2003 deployment server, Windows 2000 client that's being managed by it. The fact it's Windows 2000 is relative. It's just because the other licenses I have, it would be the same with XP or 2003 or Windows Vista or whatever you're using. Now, if I imagine here, the first thing I want to do is, if I'm going to use, say, ARP spoofing to gain access to the traffic. So if I'm just intercepting all the traffic that's on the Wi-Fi hotspot, in this case I'm just doing 2 particular IP addresses, but if I was just waiting for people to connect to a Wi-Fi hotspot with this traffic, with this software installed, this is what I'd be doing. So now hopefully I'd be having the traffic redirected to me. Now I'll just show you what I've got configured in terms of NATing rules. 402, port 402 that you can see in there, that's the main control port for Altiris. So what happens with IP tables, I'm just using a NATing rule to redirect that to my own local host. And then 666, that's one I've picked arbitrarily. If you want to transfer files, which is one of the things we're going to be doing in this attack, Altiris uses a separate dynamic port for that, which it indicates in, you may have noticed in the packets dump I showed you before, it says, I want you to grab this file, this is its name, connect to this port, and you can grab it from there. So I'm just going to tell it to use that port. It tends to change per install. It doesn't really matter which port you pick. So I'm also redirecting that to the local host. Okay. So now if I use my man-in-the-middle script, essentially this is going to be acting as a malicious server. And I wasn't actually expecting that to happen so quickly. Okay, we've already got an interpreter session. Okay, well basically there, the Windows 2000 system is then connected. The exe that I supplied it was a interpreter binary generated with MSF payload, and that's then essentially been transferred using the Altiris protocol, and then there's been a separate command issued to execute it, in which case it's connected back to my Metasploit handler here. And if you see in the interpreter with system as well, so that's obviously full control of the client. Just show you here, this is the Windows 2000 system, so the client here. Okay, what I was just doing there is the color of that indicates whether it's connected to the deployment server at the moment, so I'm just making sure it is now connected okay to the real deployment server to demonstrate the next attack. And the next attack is essentially compromising any system within the original network. So, okay, obviously this is a very similar attack, but here, I mean, the guy that pointed out the problem of server impersonation originally had kind of indicated that, okay, if something's reconnecting, then you can hijack it. But he kind of indicated that if it's not using encryption, you might be able to inject commands if you hijack an existing connection. But he kind of indicated that if encryption's being used and the connection's not being renewed at a regular interval, then you're going to have to wait for a reboot and before you can do it. But what you find is that if a connection's been forcefully terminated, then Altiris will automatically re-establish a connection after a defined period of time. It's not normally long, we're talking maybe 10, 15 seconds. Now, the only issue is that normally an Altiris connection is fairly idle. Unless someone's issuing a command, there's nothing happening. So the idea is, how do you actually forcefully terminate a connection when there's no traffic going there? You might be able to intercept it, but if no packets are being sent, if you want to use etcap to kill the connection or TTP kill or whatever, you need to know the right sequence numbers and so forth to actually terminate the connection. Otherwise, you're blind. So though this is a more generic, I guess, way of just terminating TCP connections, it came into use for me here, and I had to develop something to do it because I thought I don't want to be on a client site waiting 8 hours or 2 weeks until a system admin does something. I don't want to be dependent on TCP keeper lives or anything that's going to cause there to be traffic going between them. I just want to think, even if nothing's going on, I'd like to terminate this connection and then hijack it and gain control during the initial handshake. So essentially, what I've done is I use ARP redirection as before for the control port 402. Then I start sending spoofed TCP packets with increments in source ports to the deployment server on port 402, spoofing them from the Altiris managed client. Eventually, you'll get the right source port. It doesn't take long because, for example, if it's Windows, it tends to start from 1,000 or so, and then gradually increment throughout boot. But even then, if you're multi-threading that, you just spit out the packets. It doesn't take long at all. Eventually, you get the right one, and then the deployment server will issue an ACK packet, and then from that, you can see the correct sequence number and ACK ID at the moment. And once you know that, you can send spoofed TCP reset packets both ways, and you'll actually kill the connection. At that point, it will reconnect, and then you can issue this attack again. And that obviously doesn't matter whether the connection is authenticated and encrypted or what, and even if there's nothing going on, at that point, you've killed the connection, and it will reestablish itself. So just quickly see that here. So first of all, set the man in the middle script again. Start the ARP redirection. And then start my Scapy plugin. So, okay, for those of you that haven't used Scapy before, it's a very useful Python library for packet crafting, packet forging, and sniffing connections. So in this case, this is an extension to Scapy, that simple one that just implements the technique I've just described to you in terms of spoofing all these packets in a multi-threaded fashion very quickly. So as you see, these numbers here were just every 100 packets it's sent, it was incremented. Obviously, it sent them very fast, and at a certain point, it's hit the right one. And then it's also sniffing at the same time. And it picked up the packets meeting the right criteria, extracted the sequence numbers and ACK IDs, and then spoofed the TCP resets. So if we go back here, okay, we should have seen that as a result. Now the Windows 2000 Altiris client is reconnected. It's been redirected to us this time. We sent the file transfer request, we sent the execute request. If we go back to Metasploit, we should see we now have a Metasploit session again. So that's essentially the other way of using this vulnerability. Okay, moving on. Another new vulnerability. There's a service known as the DB management service, runs on port 505 on the deployment server. So now we're moving on to attacks against the deployment server itself. It's known as a middleman. It listens externally by default, and there was a similar code and error in this. I'm not really sure why it needs to be there, because it's meant to be a middleman between the sort of management client and the database. And it implements a sort of API and then will speak to the database itself. But then the client also speaks directly to the database. So I don't know whether it's a kind of legacy thing, but sometimes it speaks directly to the database, sometimes it goes through this. But I found, yeah, similarly to before, it's a similar protocol, similar authentication mechanism, and encryption mechanism, but you can bypass it. Now, a bit of reverse engineering, and you'll find, you look at the protocol, because by default, it's always encrypted, so you can't, before I was able to look at the protocol in the last packets by actually just looking in Wireshark and looking at some of the commands that are implemented. With this, I had to kind of go through a little bit, but you see there's some quite interesting commands, so schedule event, add user, so forth, these kind of sound like interesting commands, but as it happens, they're not quite as tasty as you'd imagine they might be in terms of launching a general attack. I mean, being able to schedule an event, yeah, that's bad, but you can't create a new event to schedule, so I couldn't create an event that says copy my interpreter over and execute it. I'd have to schedule one that's already there, and adding a user, well, actually, you need to be able to sort of connect to the system via Windows authentication first, which means you're probably going to need to RDP in, which means you're probably going to need admin access already, which means the users within Altiris, it's probably not actually that useful to you. But as it happens, it turns out that there are further vulns in the DB management that are more useful. There are ones that aren't necessarily fixed at the moment, so I won't go into detail on what they are. But I'm not so uncomfortable talking about them at the moment because really the core issue is the fact that you can bypass the authentication here. If you can access this functionality in the first place, it's not good. But it's just these vulnerabilities happen to make it a little bit more easy to exploit usefully. Okay, so now we have another interpreter session, except this time we should find that if we run sysinfo, we're actually on the Windows 2003 system, so this is the deployment server this time, and again we're running the system, so that's an attack that then means you've got everything that server controls, you've gained access to, so that could be in many environments an entire network. Okay, a couple more vulnerabilities I found. I won't demo these. They're mainly just due to time, but they're quite interesting as well. Not quite as significant as the ones you've just seen, but one of them was an unauthorized file disclosure and a denial of service in one. So I mentioned before, there's a dynamic port that's used for file transfer. That's because there's no real session control in this. So the idea is that when the deployment server tries to transfer a file to the client, it issues this packet on the control port 402 and says, I want to transfer this file to you, connect to this port and grab it. When the client then connects to that port, it just kind of sends a magic packet. There's nothing that indicates, oh, it was this file I'm talking about, give me this one. So really there's a kind of race condition there. Whatever connects to that port, and issues that magic packet, gets the content. So if something else beats it to it, then the contents are given to the attacker, not the legitimate client. So just to indicate here as a packet, you can see the magic packet that was sent was BKL in this case. I think and then it's a null byte. The B indicates here binary mode. If it's an ASCII file, it'll be an A. And just the first parts of that file you can see being transferred to an interpreter XE that was transferred before. So if you essentially make something multi-threaded that keeps connecting to this port and keeps issuing this magic packet, then you essentially will, one, gain access to every file that the deployment server tries to transfer to any clients. And that could be very sensitive. That could be a configuration script update for a database server that's got the username and password for it in it. I mean, it really depends on the environment. At the same time, it's also denial of service because the legitimate client then doesn't get it, which in one way is bad from an attacker's perspective because it means this attack's going to be detected. But But in another respect, it means you can basically prevent patching, because you can quite easily, don't need much resource, just a multi-threaded client running that can then stop an entire network being patched using Altiris. But as we said, if encryption's been enabled, then the contents of the file here will be encrypted, and so then it becomes just a DOS rather than a file disclosure as well. One of the other vulnerabilities I found was client privilege escalation. So there's been a number of these issues found before, as I mentioned previously. It's kind of maybe slightly embarrassing on their respect was that this was a file permission-based vulnerability, and in the previous version they'd fixed a very similar one. Previously it used to install to C drive /Altiris, and the directory wasn't protected properly. So then they moved it to program files and protected the directory properly. But what you found is, if you look at the permissions now, a client is the service that's running the system. That's what we're exploiting when I was doing the server impersonation attacks, and was why we were given system access. But then there's also this a client user one, which is actually the little icon in the taskbar that I showed you before, with a little blue circle. That runs as whatever the currently logged in user is. And that one had everyone full control. So if you obviously replace it or affect it in some way, then every person that logs on from then on is going to run your code. And if that's an admin, then you've got admin. So yeah, it was obviously a simple mistake on, I guess, when fixing the issue, that they overlooked this. But obviously that's since been patched as well. Okay, on to the things. There are some things I can't talk to you about today just through time issues. This is a huge piece of software. There are other things I can't talk to you about today so much just because there are issues that haven't been patched yet. But it's safe to say that some of the attacks I've shown you today I can still conduct successfully in one way or another against, or at least some of the attack scenarios I can conduct successfully against a fully patched instance of this software. There are also some ODay exploits available for sale in Vuln Disco Pack. I don't have the Vuln Disco Pack, so I don't know what they are. The only information that's given away on the website is that 1 is a DOS on a server, and 3 are client-side exploits. If I was to take a complete guess, I'd say they may be against the ActiveX control, because there's actually an ActiveX control for this, and there's been a vulnerability disclosed in that in the past. So the fact that it says client-side makes me think maybe that's the issue, but that's a complete guess. But as a real personal opinion of mine, I think there are more vulnerabilities to find. So if you're an organization looking to protect yourselves, I think you need to consider the threat agents you face here. Now, if you don't face sophisticated threat agents, then just keeping this software fully patched might be enough for you. But if you're facing more significant threats, where ODay is a legitimate concern for you, then just patching this software and configuring it it is not enough. You need to be thinking a lot more than that at the moment. In my opinion, I believe that this software was written some time ago originally, and that there are probably a lot more flaws to find, as we'll see in a moment, because it's got quite a large attack surface as well. So in terms of the further work, I think I haven't looked a great deal at the actual, from an architectural point, at the Pixie and automation environment side. I've looked mainly at the sort of control management side, but in terms of actually deploying whole new images and the Pixie side, I haven't looked at that so much. There is lots of implementation level work to do. To be honest, I haven't even looked a great deal into memory corruption based vulnerabilities yet, and there are whole network services I haven't even touched. So we'll see here, this is from the manual. That's page 1 of 2, describing what all the different network services are. There's 14 ports on the server alone. And then there are a couple of ports that get opened up on the clients too. So as you can see, this is, and they're all proprietary protocols, so there's so much room for vulnerabilities there, which is why I don't, given what I've found so far, I don't have the greatest confidence that there aren't more to find. So moving on to defense. In terms of general deployment solution advice, I think there's general questions you need to ask yourself if you're using this software. I mean, you need to consider the impact on your environment. It does very much change your environment, and so you can't just sort of plonk it in there and expect everything to be okay. You've got to think about the implications. It's definitely necessary to pay attention to the configuration and the privilege assignment. You know, the deployment server, you're granting a very, very high level of privilege over your network. So it's something you definitely need to make sure you're doing right. And if the deployment server you're using, or deployment solution you're using, hasn't been looked at much, and ODA is a threat to you, then you should consider independent testing, because, I mean, this is the only deployment solution I've looked at, Altiris, but I mean, I haven't heard a great deal about securities research into others, so there may be others with vulnerabilities as well. The other important thing to consider is actually to analyze the trade-off you're achieving here, because, as I mentioned before, a lot of people will use this software to fix other vulnerabilities. So it may introduce a threat into your network. It may introduce vulnerabilities into your network. But even if it does, you may be using it to successfully close off some very significant vulnerabilities as well, like your Adobe Radio vulnerabilities on all of your desktops. So you need to always bear that in mind as well. And it may be you get it to a point of where you're comfortable with the level of risk it's introduced, and are happy that that is less than the risk that it's also mitigated as a result of the functionality it provides. But most importantly, just protect the deployment server. That is that's the keys to the kingdom. And if you don't protect that, then your whole network's at risk. So, in terms of Altiris-specific defense, apply patches. All the issues I've described today are patched now. One of the things I've noticed in tests I've been on is that this software often seems to be overlooked in terms of updates. And that's actually possibly because it's the mechanism used to update other things, that people will be using WSUS to update Windows, and they'll be using this to update every other piece of software they've got on different systems. And it's the one sort of manual step left that gets left. So I've been on plenty of tests where I haven't needed to use any of the vulnerabilities I've discovered because older ones have affected it. And they've been an organization that are very good at keeping up to date with most pieces of software they use, including other third-party components. And then, this is running a version that's 3 years old. So as sort of anecdotal evidence, that's obviously something that's worth considering. Okay, in terms of communication security, yes, Altiris does provide authentication and encryption. Okay, they may have fixed the simple vulnerability I found in terms of authentication bypass, but really, do you want to be using a custom kind of encryption authentication protocol when there are already very well tested solutions out there, such as SSL, SSH, IPsec, for example? Now, I appreciate it's maybe not the easiest thing, but if possible, I think probably the best solution, if you can get it working, would be to use IPsec through group policy to protect the particularly sensitive ports there. So, for example, 402 has been the control port. If you can have IPsec providing authentication and encryption on this port between all your clients and your deployment server, then I think you're in a much better position than them relying on Altiris' own mechanism. Another possibility would be S-tunnel. I think this is probably difficult though. It's not something I've tested, but I think perhaps if you're going to be setting a deployment server as the local host rather than the actual IP address and then S-tunneling through that, like port forwarding on, then it may cause other application level issues if IP addresses are passed in control ports. And I'm not sure it would be very easy to work, but if anyone tests that, then be sure to let me know. I'd definitely be interested if it's a workable method. In terms of defense in depth, as I've pointed out before, there's lots of services exposed by default. I think you can really reduce a lot of risk just by using a firewall properly. But I think I found that a lot of people see all these services open as a perception, oh, these are, they're in the manual, oh, these are needed for, for the working device. We need to open all these up. And that is made somewhat more trickier by the fact that there's a dynamic file port, so that can change per install. And I can imagine that a lot of people trying to set it up have tried to go with a sort of normal denial firewall policy and then found, oh, it just doesn't work. Okay, we need to open up all the ports. But I think at the very least, block these 3 ports here. 505 is the DB manager port. for which you showed the ability to actually compromise the entire server before through. 8080 and 8081 are used for the web administration console. So again, you know, they're all just 3 administrative services that don't need to be available on your network more generally. So just lock them down to the hosts that need to access them. I mean, in fact, a lot of installations you'll find that there's one deployment server that, you know, the database is on that and the web interface is on that, and actually everyone managing it is logging in via RDP, and none of those services need to be available beyond the local host. But if you lock down, you know, as many ports as possible, then even if there are ODAs still left in them, then you're going to be protected. And also the configuration level. Altiris opens a file share by default, which is used for distributing certain contents, and what it actually does is just opens its entire install directory. So you've got to pay attention to the permissions for the account you're using that's configured for that. If you enable write permissions, which doesn't seem to be uncommon in practice from what I've seen, then you know you'll get your deployment server trojaned, or you'll get exes that are distributed to clients trojaned. So that's definitely something that you need to consider as well. Okay, so in conclusion, deployment solutions can heavily impact security. Altiris in particular, as we've obviously seen today, has significant vulnerabilities, and it can significantly affect the security of any network it's deployed on as a result. So if you haven't considered the issues I've outlined today, then perhaps your entire network might be at risk. And if you're a pen tester like myself, then you should probably be thinking about this when you're on test, because it may be a way of getting you root on a whole network. So yeah, I mean, you know, other than that, just get thinking about these issues. And I guess now, any questions people might have, I'll be happy to answer.
Thank you, Luke Jennings. If somebody has a question, could you raise your hand so I can approach you with the microphone, because this is being taped. Nobody, any questions? I guess it's too early in the morning. So probably you could give us an example of what size these development environments could range from. Like, what is the smallest size you would probably start thinking about these problems?
I think it's used in quite a wide variety. I mean, I've seen people use it just for managing smaller subsections of their network. So I've seen people that have deployed sort of Citrix solution, and they've used it just for managing their Citrix servers, and in that case it's only directly responsible for maybe 10 or 20 servers. But then again, obviously they are used by thousands of users, so it does have wider implications. Then I mean, some of the bigger networks I've seen it on have got 10,000 desktops, and everything, servers and desktops, is managed by this, and I could obviously compromise the entire network through it. So it's going to be the bigger, more dangerous networks are the ones that are affected by it, certainly.
May we ask which other solutions you've looked at other than Altiris in your research? I
haven't, well, not to the kind of the level I've looked at this. I haven't looked at any other solutions. I've seen what other people have written about some other ones, but that was mainly with regard to thin client installations, and actually in that, they were kind of marking Altiris as being the secure one, because from what they were saying, Altiris has the ability to authenticate and encrypt, the others don't. So, I mean, if there's these kind of vulnerabilities in Altiris and that's being listed as a secure one, then I hate to think what you might find looking at any other solutions.
Okay, thank you. So, any one question left? No. Thank you, Luke.